Okay, last video we put together two equations. One describing the time it takes the rock to fall in terms of the height. Actually, we derived one exactly like this in lab. This was how long it takes the ball to fall out of the exactly as the lab. This was how long it takes the ball to fall out of the gun. Exactly same as the lab. Exactly the same expression. And this is the expression for how long it takes the sound to come up from the bottom. The only problem is we don't know this height. But we do know one thing. Together, the time for the rock and the time for the sound together is 10 in my question, 10.9 seconds. So we can combine these two expressions and have them together equal 10.9 seconds. So I'm going to put, just for convenience, I'm going to put this is the sound and this is the rock. So this says why the top of the position at the top of the gully over 330 meters per second plus square root of yt all over 1/2 9.8 meters per second squared is equal to 10.9 seconds. All right. Now, it's not very easy to see. So I'm going to erase everything, assuming that people were able to generate these two expressions. And this is a restatement of this equation. 10.9 seconds is equal to the total time. We calculated each one of these individually based on acceleration or based on just a straight velocity. I appreciate that it's hard to see, and this is the, maybe the unfairly difficult part of this equation, of this question, which is why I don't feel bad helping you here. Let's look at the form of a quadratic equation. A quadratic equation is normally stated as ax squared plus bx plus c is equal to 0. You have a squared term, a linear term, and a constant equal to 0. Well, yt is in some weird way, I can restate yt as the square root of yt squared. Because the square root of a number, all squared, is equal to the number itself. Here's yt, this is still yt. And this is 1 over 330. I'm going to drop the... and this is the square root of yt with the coefficient out in front, 1/2 9.8. it's just what's left here. And c is equal to negative 10.9. I just brought it over. Seconds is equal to 0. Now what the heck is this? This simple equation, what I'm trying to point out, can be seen as a quadratic equation where x is taking on the role of the square root of yt. So now when we try to substitute this, not substitute, when we try and solve this quadratic formula, the quadratic formula says, well, if you have this structure, then x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. In our case, when we substitute in, what plays the role of x is here. Here it is square root of yt is equal to negative b. b is 1 over square root of 1/2, 9.8 meters per second squared. Actually, I should have used, I'm going to write exactly the same thing but in a different colored pen, so it's not mixed in with this equation above. We have square root of yt is equal to negative b, which is negative 1 over the square root of 1/2, 9.8 meters per second squared, plus or minus square root of b squared. This is b again. B squared is 1/2, 9.8 meters per second squared, minus 4ac. 4. A is 1 over 330 meters per second. C is negative 10.9 seconds. All over 2a. A is 1 over 330 meters per second. So, we took this simple little time equation where the total time was equal to 10.9. We calculated, or we derived that the time for the rock was this, and the time for the sound was this in terms of yt. And then we used our imaginations to recognize that this is a quadratic equation, not in y, but it's quadratic in the square root of y, where a variable and its square root can have a quadratic relation the same as the square and the variable can have this relation. Plugged in, I substituted into the standard quadratic formula. Instead of x, our variable is square root of yt. And that can be solved. Just with some care and a calculator, this can be solved. And you'll get an answer. You know everything here, it's just a number. That's equal to the square root of the height. And therefore the height is just whatever you calculate here, all squared. Not all questions, I assume, all students can do. Do as many as you can, and if there's some epic questions on each homework that you can't do your best, and just hats off to those who can do it.